Good morning, friends. I, Dr. Devis Mandel, Associate Professor, Suresh Gyan Vihar University, accredited by NAC, A grade. Today, today I will discuss about linear search technique. You know, linear search technique uh, is the technique of your searching. Searching, when you will search the any item from the given array, that is your searching. Suppose you are having a array in which items are 1, 5, 9, 10, 12, and 13, and you want to search the particular 12 item. Okay, so your linear search is the technique of your searching, and through the linear search you will search the item from the given array. Your searching is the main important topic of your data structure and algorithm. That's why you should know what are the object and outcome of this subject, that is your data structure and algorithm. If we will talk about the object of your data structure and algorithm, so to emphasize the data structure concept, to emphasize the algorithm, to emphasize the complexity of algorithm, to emphasize the stack, linked list, searching, sorting, etc. And after studied this paper, student will able to how to write the algorithm, how to find the complexity, how to use the stack, what are the application of your stack, how to use the linear search, how to insert the item in your linear search, either if you want to insert the item at your starting level, at your middle level, and at your end level. And also student will able to searching and your sorting. After studied this paper, that is your data structure and algorithm, student will also able to so many techniques of your searching, that is uh, in which student will able to how to define the linear search, how to implement the binary search for search the item from the given array. In the same manner, if I will talk about the sorting, student will able to, after study this paper, how to apply the sorting techniques like your linear like your radix sort, like your insertion sort, like your selection sort, like your merge sort, like your radix sort. There are so many techniques of your sorting. Okay, and after studying this paper, student will able to write the use the technique of your sortings, right? And here I will discuss about the linear search. you know I had told about the searching when you will search the item, when you will find the item from the given list, from the given array, that is your searching. And your searching are of two types. First, you can use the linear search for search the item from the given array, and also you will use the binary search technique for search the item from the given array. And here I will discuss about the linear search. If we will talk about the object of this lecture, so the object of this lecture is to understand the concept of your linear search. And if we will talk about the outcome of this lecture, the outcome after studied this lecture, student will able to how to apply the linear search. Okay, now I am sharing my PPT of linear search algorithm, linear search technique. I hope you can see my PPT of your linear search. But during this lecture, I will discuss so many topics which are related from your linear search, like your what is searching, what is your linear search, example of your linear search, algorithm of your linear search, implementation of linear search, and end of this lecture also I will discuss about some questions which are related from your searching technique, that is your linear search. So first I will discuss about the what is searching. Searching is the process of finding the value in a list, that is your searching. In other words, also you can say that searching is the process locating given value position in list of value. For example, suppose you are having array, and in your array there are 8 items are already inserted. Okay, like your 5, 7, 9, 10, 11, 13, 18, and 19. Your array, if we will talk about the index of your array, so your array index will start from your 0. So at your 0 location, your first item have to be inserted. At your location, have your second item is inserted. In your third location, your third item already inserted. In your fourth location, there are item already inserted. In your fifth location, in your sixth location, in your seventh location. And here I am taking the size of array is 8, is your 7, sorry. And if you are taking the array size of your 7, so your array will start from your 0. And if you will take the size of your array is 8, so your indexing, you start from your 0 to 7. Means your one item has already inserted in your 0 location, in your 1 location, second location, third location, fourth location, 5 location, and 6 location, and your seventh location. If you are having a size of array is your 8, and you want to search the item which are inserted in your fifth position, so you can search the item from your linear search and from also binary search. And here I will discuss about the linear search. Through the linear search, how to you will search the item from the given array. So I had told about the searching. Your searching is the process of finding the value in a list value, and in other words, you can also say that searching is the process locating given value position in list of value. Means you want to search this value, your that value have to be inserted in which location of your array. You can take the example you can see here. Suppose you are having a list. In this lecture, I will take more than one example of your linear search. I hope through the example, student can understand about the linear search in a better way. Here, I had taken a list in which your items are already inserted: 65, 20, 10, 55, 32, 12, 50, and your 99. You know, total 12 items. Okay, sorry, total 8 items. And suppose you want to search the element 12. So in this list, your first item has already inserted in your zero location, second item in your first location, your third item in your second location, fourth item in your third location, fifth item, sixth item, seventh item, and your eighth item are already inserted in the list. And that is your 65, 20, 10, 55, 32, 12, 50, and 90. And you want to search the item 12. Okay, so in your step first of all, your search item 12 is compared with the first element of the array. Okay, your first element is your 65. Your first element is your 65, which has already inserted in your array. So first of all, your searching item, that is your 12, will compare from your first item of your array, that is your 65. Your 12 is not equal to 65, means here your searching item has not found. Okay, and again, your in your second step, your searching item 12 is compared with the next element of your array, that is your 20. And your 12 is not equal to the 20. So here also searching element, that is your 12, has not found. And in your step third, your searching item, that is your 12, will compare from your third item, that is your 10 of your array. Your 12 is not equal to the 10. That's why here you have not found the searching element 12. And again, your 12 elements will search from your 55. 12 is not equal to from the 55. Again, your 12 will compare from your 32. Your 12 is not equal from the 32. And again, your 12 element will compare from the item which have already inserted in your fifth position, that is your 12. So your 12 is equal to the 12. So here you have to find the searching element, that is your 12. Suppose your searching item has not found in your array. So that time you will find the message, your searching item is not present in your given array. Either you can find the message, your searching item is not found in your given array. Okay, so that is the example of your linear search. And through this example, I hope you can understand the concept of your linear search in your better way. Again, I am taking the another example of your linear search. You can see in this given slide, I had taken a array. Okay, and your array size is your 9. Okay, and you can see in this given slide, your first element has inserted in your zeroth location, your second element, that is your 50, inserted in your first location, your second element, that is your 30, in your second location, your 17 element, that is your inserted in your third location, your 80 element in your fourth location, your 60 element in your fifth location, your 60 element in your fifth location, your 20 element in your sixth location, and your 19 element in your seventh location, and 14 in your eighth location. Means in this example, I had taken a size of array is 8. Okay, and also I had taken a element 20, and I will search the 20, this item from this given array. Okay, you can see in this given slide, your 20 value has already inserted in your sixth index, because your indexing of array will start from your 0. And here you have taken the size of array is 9. That's why your indexing will start from your 0 to 8. Okay, so in this In this image, you can see first of all your searching item, that is your 20, will match from your zeroth index item. Okay, you know your zeroth index item is your 10, and you know your 10 is not equal to the 20. Again, your searching element, that is your 20, will compare from your second element of your array, that is your 50. You know your 20 is not equal to the 50, and again your the searching item 20 will match from your 30. You know that is not equal, and again your 20 item will match from your next item, that is your 70. So here you have not found the searching element because your 20 is not equal to from the 70, and again your 20 item will match from your 80. Okay, and here also you have not found the searching element, that is your 20, because your 20 is not equal to the 80. Again you will compare the searching item, that is your 20, will compare from the fifth location, and that is your 60, and that you know these are not equal. And again you know your in your sixth index your item has already inserted, that is your 20. So you know, and your searching item will also your 20. So you know your 20 will equal to 20. So means here your searching item has to be found, that is your 20, in your sixth location. In your sixth location. So that is the another example of your linear search. Okay, here I had discussed about the two examples of your linear search, and I hope from these two examples you can better understand about the linear search. And after that, I will implement this algorithm linear search. So how to be implement this algorithm? How to implement this technique, that is your linear search? You know, you can implement the algorithm in any other language. There is no any foundation key. You will only implement this algorithm only in this language, only in this language. There is no any limitation. You can implement in any language, either your C language, either C++ language, either Java, either PHP, either C Sharp, either VB, Visual Basic, etc., etc. Here I will implement this technique into your C language. You know, if we will talk about the C language, so in your C language, first of all, you will inserted the header files in which your some input and output functions are already declared, like your stdio.h header file. You know, your printf and scanf function definitions are already included in your stdio.h header file. Okay, and when I will implement this algorithm, so first of all, I will make a function. Okay, you know, you can make the function of any name, that is depend on you, because you will make the user defined function. And you know, user defined function, the function name is depend on user. You can define the function name any whatever you want. So here I will define the user defined function, that is your searching. So I will make a function search for search the item. And you know, every function will always return the any value. Okay. By default, any function will always return the value is integer type. And if you want to your function will return the value other type, like your float, like your char, etc. So you will explicitly mention the return type of the function. And here is also mention the integer return type of the function search. Okay, and in this function I had taken the three parameters. First of all, I had taken a array, and your second parameter is the size of your array, and uh, and n is the another variable, another parameter, and x is the another parameter. Okay, and your function body will start from your opening curly braces, and here I had taken a variable I of integer type. Okay, and your loop will start from your 0, and your the value of your I will less than from your n and your I plus plus. Okay, here your n is the size of your array. N is the size of your array. Okay, so first of all you will write the condition if your array item is equal to the x your means your searching item. Here I had taken a x for the searching item, and in this given examples your 12 is your searching item. Okay, and for the implementation when you have to taken a array. Okay, so your from this loop, when your loop will start, that time the value of I will be 0. This is your initial value of your I, that is your 0. So means your 0th index item will match from your searching item. Okay, if your 0th index item have to be matched from your searching item, so that time your 0th index item will be your value who want to search. Okay, and otherwise your return -1. Okay, so means for the implementation of this technique you will start the loop from the 0, and your loop will start from 0 to less than n is your size of your array. Okay, so first of all your 0 is the initial value. So first of all your 0th location item will match from your searching item, that is your x. If your 0th location item have to be matched from your searching item, that is your x, so your searching item has to be found, otherwise your searching item has not to be found. Okay, and after that you will apply the main function. And before that I would like to explain, suppose your 0th item is not matched from your searching item. Okay, so again your the value of I will be increased. That time your I will be the value of I will be 1. Okay, and suppose you have to taken the size of array is your 8. So your 1 is less than your 8 means your condition is true, and that time your one location of your array item will match from your searching item. If your that time your one location item will match to your from your searching item, so your searching have to be finished and your one location item have to be searched item. Okay, and suppose your one location item has not matched from your searching item, so again your the value of I will be increased. That time your the value of I will be 2, and your 2 is less than from your 8, and after that your second index value will match from your searching item. If your second index value have to be matched from searching item, so your searching has to be finished. Means your this process will be continue until your searching item has to be found. If your searching item has not to be found, so you will fire the message your searching item has not to be found. And after that you will write a main function. Okay, you know your main function is your user defined function. Mostly persons having will have the confusion, your main function is your user defined function or your library function. So here I am clearing, say, your main function is a user defined function, because this function is made by you, because this function is made by user. And after that, suppose I had taken the array items, that is your 2, 3, 4, 10, and your 40. So these are the five items. That time, the index, the size of your array is to be 4. Your array will be start from your zeroth location, and here you have to taken the five items, means in your zero location, your item, that is your 2, in your one location your item will be 3, your second location your item will be 4, in your third location your item will be 10, in your fifth location your item will be 14. Okay, and x equal 10, that is basically, that is not a equal, that is your assignment operator. So 10 is your searching item, means you will search this item into given array. Into given array means in which you have taken the five item, that is your 2, 3, 4, 10, and 40. Okay, and after that, your size of array, will assign into n, as per I had told. Your n is the size of your array. Suppose you have to taken the 9 item, so your array size will be your 8, because your array size will be start from your 0 to 8. Okay, and your array size will assign into the n. N is the value. Your n is the size of your array. After that, your function will call, which function you have to make, that is your searching function. You can see here, that is your search function. And when your search function will call, okay, so your value will assign into the result which you want. Okay, if your result is equal to -1, if your result is equal to -1 means your searching item is not present in your array. Your searching item has not to be found in your array. Okay, and otherwise, your printf element is present at your index. That is your conditional operator. Your condition is that result equal to -1. If your condition this true, so your element will not present in your array. If your condition this false, your element is present in the given array. Okay, so I hope you know about the conditional operator. Okay, that is the operator in your C++ and any other programming language. So here I have to use the conditional operator for print the message. If your result is equal to the -1, so means your element has not to be found in your given array. And if your this condition is false, so your element is present in this index, and you will return your 0, means here you will write the function getch. Okay, and after that, if we will talk about the time complexity of the above algorithm. The time complexity of the above algorithm is your n. Okay, and your linear search is really used practically, because other searching algorithms such as your binary search algorithm and hash table allow significantly faster searching comparison to the linear search. When I will talk about the binary search, so your binary search and your hash tables allow significantly fasting algorithm compared than to your linear search. Your linear search technique is slightly uh, not efficient, okay, compared than your binary search. And Improve linear search worst case complexity. If we will talk about the linear search worst case complexity, so if your element is found at last, so that is your will start from n to 1, and if your element not to be found, so your start from n to n upon 2. And after that, we will discuss about the algorithm of your linear search. Your linear search technique is a simple technique. Your linear search technique is your simple technique, and for the linear search algorithm, you can write the algorithm in your better way. You know, algorithm. Your algorithm is your step by step instructions in a sequential way. Your algorithm is that step by step instruction in a sequential way for find the goal, for find your object. Okay, there is no any foundation for the algorithm. You will write only at your first level, you will write only this instruction, after that you will write this instruction. There is no any foundation. Only if you want to write the algorithm, so only you will follow this technique, that you will write the instructions step by step in your sequential way. Okay, so when you will write the algorithm for the linear search algorithm, so first of all, in your first step, your searching element will the compare the elements, and your searching element comparison will start from your first item. In this given example, as I have taken, your searching element was your 12, and your 12 will match from your first item of your given array. So when you will write the algorithm for the linear search, you will write the all instructions step by step, and in your algorithm you will write your searching item will match from the first item of the given array. If your searching item have to be matched from the first item of a given array, so you will print the searching successful. Your search element has to be found. Otherwise, your searching item will match from the first item of your will match from your second item of your given array. If your searching item will match from your second item of your given array, so your searching is successful. Otherwise, you will print the your searching is unsuccessful. And here I have inserted some questions in this given PPT, which are related from this lecture. Question is that where is linear searching used? So Your first option is that when the list has only few elements, when performing a single search in an unordered list, used all the time, when the list has only a few elements, and when performing a single search in an unordered list. So, I had already discussed about that. Your linear search will be used when the list has only a few elements and when performing a single search in an unordered list. So means your that is your answer is your D. And I have already inserted the other questions which are related from this lecture. What is the best case for linear search? Your first option is that your n log n, n log n, log n, n, and your 1. So the best case for linear search is that your 1 means your answer will be D. And what is the worst case for linear search? Your n log n, and your 1. So, if we will discuss about the worst case for linear search, so that is your n. And what is the best case and worst case complexity of ordered linear search? That is your n log n, log n, log n, n log n1, and your 1 and n. So the best case and worst case complexity of order linear search, that is your 1 and your n. And what does the following output of this code? Your code is your loop will start from your 0, and your the value of I will be less than from array dot length minus 1 I plus plus, and your loop in j equal to I plus 1 less than array dot length j plus plus if array I dot equals array j and operator I is not equal to j, and system dot out dot println. Here this code is written in the Java language. Okay. And your options are: print the duplicate elements in the array, print the element with the maximum frequency, print the unique elements in the array, print the element with minimum frequency. So, print the duplicate elements in the array, and you can judge from these given code. And which of the following is a disadvantage of your linear search? Here, I will discuss about the disadvantage of your linear search. You know, here is options are: require more space, greater time complexity compared to other searching algorithms, not easy to understand, not easy to implement. Okay, so if we will talk about the disadvantage of your linear search, so the disadvantage of a linear search is that greater time complexity compared to other searching algorithm. Other searching algorithms like your binary search algorithm means if you will compare the linear search from the binary search. So the disadvantage of your linear search, this technique, greater time complexity if we will compare to the other searching algorithm, that is your binary search. And now after study this lecture, student will able to give the answer of following these questions, like your what is array, what is your linear search, how to write the algorithm of linear search, how to implement the linear search, and what is the complexity of linear search. Okay. I am again explaining, I am again saying about the array and linear search. Your array where your item will be stored, of a same item, means where you can store the same type of item is called the array. Suppose you want to store the 100 students, so your all students are same. Suppose you want to store the marks of your 100 students, So your all students marks are of your integer type, so you can store in your array. And next is your, what is your linear search? Linear search, in your linear search you will take a limited size of your array. You will take a size of your array, and your searching item will compare from the first item of your array. If your searching item has to be matched from your first item of your array, your searching is successful. Otherwise your searching item will match from the other item of your array. And you know how to write the algorithm of your linear search. So when you will write the algorithm of your linear search, so you will write the only instruction step by step as per I had told. How to implement the linear search? So you can implement the linear search in your any programming language like your C, C++, etc., etc. What is the complexity of your linear search? Already I had discussed about the complexity of your linear search. I hope you have to understood about the linear search, like what is your linear search, where you can apply the linear search. Okay, and how to write the algorithm for your linear search, right? And I hope you have understood about this lecture. Thank you. And in this lecture I had discussed about the one searching technique, that is your linear search. And in my next coming lecture I will discuss about the binary search, that is the another technique of your searching. Thank you.